Hi students. So in this session, we will discuss regarding the concept of work and power in terms of line integrals. So what it is? The concept of work and power in terms of line integral. So you know that what you mean by work. So work is said to be done at what times? Only when the force applied on an object causes it to move through the distance in the direction of forces. The work is said to be done only when a force applied on an object causes it to move to a distance in the direction of applied forces. Or the SI unit of your work is joule, and work is a scalar quantity, and is measured by the product of force into displacement. So that F is equals to F, sorry, it's F, W is equals to F into S. W equals to what is F into S. When do you say that the amount of work is said to be done 1 joule? The amount of work is said to be done 1 joule if the point of applications of a force of 1 Newton undergoes a displacement of what is 1 meter in the direction of applied force. In such cases, the work done is said to be 1 joule. The work is said to be 1 joule at what time? If a force of what? 1 Newton, the F is equal to what? 1 Newton. If it undergoes a displacement of how much it is? 1 meter in the direction of applied force, then the work is said to be what is 1 joule. The example for your work is a horse pulling a cart. Second one is a man pushing a wheelchair, weightlifter lifting a barbell. So these are the few examples of what is the work is said to be done only when that your applied force or the force applied on that object causes or produces and what produces it to move to a certain distance in the direction of applied forces. Okay. So at what time that amount of work done on the objects by the force is maximum? When it is zero, and at what time the amount of work is in negative. So we will discuss one by one. So see here, this picture so indicates that block is nothing but a certain rigid objects or any heavier object. If the applied force makes a certain angle with the displacement, then the amount of work done on your object by the force, that's work is equals to F cos theta into what is d. What time? When your applied force makes an angle in the directions of your displacement of the object, then the work is equals to F cos theta into what is and dx. Okay. So when the amount of work done on the object is maximum, if theta is equals to 0, when theta equals 0, the cos theta equals to 1. So in this equation, W is equals to, you are getting what? F into D. That indicates the force of applied force, means the force and the displacement are in the same directions. When the applied force is in the directions of your displacement of an object, in that case or in such cases, the work done on that object is maximum. Okay. So that's F you are getting W is equals to what is Fs. Suppose if theta is equals to 1 degree, then you are getting what? Cos theta equals to minus 1. So here, when you are getting cos theta equals to minus 1, that above equation becomes what? The W is equals to W of cos theta into D is there. So cos theta is minus 1, you are getting a W is equals to minus of, you are getting what? F(s). So it indicates that what? The force and the displacement are acting in what opposite directions. So at what time? So the zero work is done on that object. When theta is equals to 90 degree, the cos theta, the cos of 90 equals to 0. That means your applied force is perpendicular to the displacement. So in such cases, the work done on an object by your force is equal to 0. No work has done on that object. So this picture are shown in the figure of C. Okay. So it indicates what? When the force acts in the directions at right angles to the direction of displacement, so no work is done. That means zero work is done on that what object that remains in this initial state what only is. Okay. So at what time that the positive work is done is, that means the theta is lies in 0 is less than theta, the theta is less than 90 degree. That means your cos theta is positive. So in such cases, the force has a component in the directions of what is displacement. So when theta is lies between 0 is less than theta, theta is less than 90 degree. In such cases, the amount of work done on that object is positive. That is W is equals to what is a positive work is you are getting it. Okay. So at what times that negative work is done on that object? So the theta is lies in what? 90 is less than theta. The theta is less than what? 180 degrees. So in this case, the cos of theta, the cos values we are getting what is negatives. Okay. So the force has the components in the directions opposite to the what? A displacement. So W becomes what is negative. So this one is also shown in below figures. Okay. So that the work done by the force is negative. The work done by the force is negative if the angle between a force and displacement is what? Up to 6. So that your cos of theta is negative. It signifies this suggests that when the force and displacement are in opposite directions, work done is negative. This work is said to be done by the bodies. Okay. So these are the pictures. This theta is equal to 0. This is theta is equal to 180 degree. That's W is the force and the displacement are what? Acting in opposite directions. W is negative here. The theta equals to 90 degrees. This indicates what? No work has done on that object. So here the theta equals to again it is 0 degree. And this one is some values. That's 5 or 10 degrees. Positive work indications. Okay. So after the concept of work, let's come to another important concept. So in this session is that is power. So we know that what do you mean by a power? Power is given by an equations. Here I have done W divided by what is T. So W is nothing but in what? Work. Simply, the simple statement for your power is the rate of doing work. The time rate of doing work is nothing but, or the rate of doing work is nothing but what? A power. So on what basis the power of that engine or any person can be measured by a quantity W P is equals to what? W by T, the rate of doing work. On the basis of is performance of work with respect to time, that the power of that engine, the power of the object is what measures. So simply, so we can define what the rate of doing work is nothing but what is power. So here it is again similar to that your what work. It is also scalar quantity. Its SI unit is watts. Its SI unit is what it is watts. So when do you say that the power is said to be 1 watt? So we are having what is W divided by T. If 1 joule of work is done, the time rate of doing work is nothing but power. When a 1 joule of work is done in 1 second, when W is equals to 1 joule and T equals to 1 second, then we are getting what? P equals to 1 watt. The power is said to be 1 watt if 1 joule of work is done in 1 second. Okay. So here, let us write that the work and power. So those two terms in terms of an line integral is. So thus, if F dot ds is the work done by the force in moving the particle, for that, let us consider a path. This one, this indicates a path of the our objects starting from A to what is a B. So what amount of work has done in moving that object from the point P to and what are P dash. So to determine the work done, consider the two neighboring points. So here the P and what? The P dash are the two neighboring points. So here we are going to determine what? The amount of work done in shifting the particle from the point P to what is a P dash. So that's why he's saying that what? Consider the two neighboring points P and P dash with the position vectors R and what? R plus dr. So with respect to some chosen object, or we can call it the fixed reference point. So we are pointing the distance of the particle P with respect to O, it is R, whereas the distance of your P dash with respect to your O is what? R plus dr. Okay, so then, and one more thing, this P dash, the change in displacement of your particles from P to P dash is designated by what? D of R. So that's the P of P dash equals to what is dr. So therefore, the work done by the force in displacing the particle from the point P to P dash along the curve is given by dw is equals to F into ds. So here, so we are finding what amount of work has done in moving your object from the point P to what P dash is given by dw is equals to F into ds, and whatever the work has done in shifting your particle from the A to what P along what the entire curves. So for that you have to integrate the dw between the limits A to what is B, so that we are getting what W is equals to integration of A to integration of what is A to B dw, but dw is equals to F into ds, but F into df is having a component, it makes a certain angle. So with our what displacement of an object, so that we are getting what F cos theta into a ds. So this is the what the amount of work done in shifting object from the point A towards B along this your path. Okay, in terms of its words line integrals. So similarly, we have to write. So what is the power in terms of what is line integrals? So as I said, the power is nothing but what the rate of doing work is called power. If F into ds is the work done by the force, F moving the particle from what P to P dash, then the rate of doing work is power, and it is given by so P is equals to what dw divided towards dt. The W is equals to F dot ds by dt. So that's is equals to what? It is what F into bracket d into ds by it is what dt. So we know that it is what the change in your velocity with respect to time is nothing but your what is which one is velocity. That's why. So here at what you have got v, where v is the what instantaneous velocity. V is the what is instantaneous velocity. So here the rate of change of d of ds divided by dt is nothing but your what is velocities. Okay, and that's why. So v is the it is what is instantaneous velocities. So therefore, the power in terms of the total power utilized in moving an object from the point A to B, P is equals to integration of A to B dw divided by what dt. Then we are getting what the above one. So amount of work done or the total force it's what total power. The total what is the power is obtained. So what amount of power is there in shifting your what particle from the point P to is what P dash is. Okay, so that's obtained by integration of what is A to B dw by what at dt. Okay, thank you.